Greetings, everyone. Today I'll be presenting on medical insects. Now, insects on the whole, when persons think of them, are thought of them in the sense of being pests. This is probably because of their more common parts or common numbers in the agricultural field or in the garden, where most persons are exposed to them damaging their crops or plants and soil. But but we're more familiar with the ones that spread diseases, such as the houseflies, the roach, and mosquitoes, and so on. Now, due to this, many persons think that insects are very harmful and do not have much good. But quite on the contrary, more than 90% of insects are not only harmless to us, but also very much they have various benefits, such as pollination of higher plants. And when we say of higher plants, these are like plants which have their male and female parts separated and would require some form of pollinating agent in order to produce offspring as well as fruits and so on. Insects are one of these very important pollinating agents. Whilst they may be wind and water and so on, they are not as consistent or as numerous as insects would be, or more effectively as them. Secondly, they help to decompose organic matter and other waste materials, such as dead plants and animal materials, um, feces, and etc. Without them, there would be a large pileup of all of these decomposed materials. Now, thirdly, they can also serve as a food source. In the food web or food chain, they play critical roles as food source for other organisms, such as the frogs and so on. And as you know, removing one aspect from the food web could cause potential collapse because the other organism above them would then not have a food source. They can also serve as a food source to humans. In some culture and parts of the world, there are persons who feed on insects. Um, but for the rest of this presentation, we'll mostly be looking at their final use listed there, which is their use in medicines. Now, when you speak of insect use in medicine, you are basically talking about entomotherapy. And to simply define it, it's basically the use of insect or insect products in the medical field, right? Um, right here we have for entomotherapy. You have cantharidium, which is a chemical you'll see produced by some bugs belonging to the Coleoptera order. You also have anticoagulants, which are inspired by some blood feeders like mosquitoes, ticks, and houseflies. Then you have maggot therapy, which is, as the name suggests, the use of maggots um, in medicine, which maggots are the larva stage of houseflies. Houseflies belong to Diptera, as we know. Then we have apitherapy. Apitherapy is basically the use of um, bee products. This concerns the Hemi, Hymenoptera family, but specifically, we would be going to the honeybee and not all of the other members of Hymenoptera. Now, on fourth on this list is the Cantharidium, which is a chemical produced by some bugs previously mentioned. from the Coleoptera family. Now, Cantharidian. Cantharidian is basically a chemical compound that is highly acidic in nature. Um, it is used as a defense mechanism by these insects, which they can secrete from their joints to prevent from being eaten. Now, two bugs that is famously known for producing this chemical are the Spanish fly and the blister beetles. Now, as the name might suggest, blister in it, um, they get their name because the chemical is so highly acidic that when when you expose your skin to it, it can cause blisters to occur. Um, now, now you think that something so highly reactive, um, what benefit it would have? It basically can be used to treat skin disease, such as warts and molluscum contagiosum, which is a viral infection. Now, it is not really life threatening, but it is still a disease and it would not be favorable to live with it. Now, in small dosage, cantharidian can help to remove this or get rid of this disease. The disease would usually cause bumps and ear and rashes to occur. In small dosage, it can eliminate the virus from the skin and thus giving the person relief. Secondly, now we have anticoagulants, which are inspired by blood feeders such as mosquito, houseflies, and ticks. Now, as we know, the blood feeders feed on the blood of their host, where they would um, use their mouthpieces, whether it be to inject their proboscis and suck up blood. Now, seeing just sucking up blood is kind of doesn't do the trick. Now, how they get to suck up blood after they penetrate the skin is something we should know because after they pierce the skin, or if an injury occurred to our skin, we know that our body have the natural effect of clotting, right? Where it would clot the blood to prevent any release, any further escape of blood. Now, why this doesn't happen when the blood feeders penetrate our skin is because their saliva contains blood thinning agents. Now, these agents help to prevent the blood from clotting, and thus they can have a easy flow of blood into their stomachs. Now, how this is applied in medicine is that naturally in our body, we can show own blood clots in the blood vessels, such as the artery and the veins. Blood clots can occur from now and again. And when these blood clots occur, the blood flow is either reduced or blocked up. So, if these anticoagulants can be applied at these regions where the blood clot has occurred, it can then provide easier blood flow, like remove the blood clot and allow the blood to flow easily again. Um, a second use of these blood feeders is that some compounds in their agents, some chemical compounds in their saliva can help to suppress the immune system. Now you think that this would make a person weak, but in some cases it is beneficial. When a person is usually plagued with cancer, suppressing the immune system during certain treatments is favorable to getting rid of the cancer. Um, it is also used after some amount of organ transplant, since the organ may be seen as a foreign object to the body. The immune system might respond and reject the um, organ. But if the immune system is suppressed, they would not have that much of a strong reaction to the organ, and thus it would give time for the organ and for your immune system to get acquainted, and thus it would no longer be considered a threat by the immune system. And that's it for anticoagulants. But and now we move on to maggot therapy. Now, maggot therapy is, as the name suggests, we use introducing maggots to certain wounds. Now, the use of maggot therapy was found during wars or during the time of war, where there weren't much antiseptic materials, and medical soldiers found that wounds that have maggots present healed not only better but also faster, and it had much more survival rating than if a person did not have any maggots. After a time, this theory was tested and found to be true, and further study was done, and it found and it what was found was that maggots have the ability to distinguish between necrotic and living cells. Oh, when you say necrotic, you mean the dead cells. And by this, they choose to they selectively choose to feed on necrotic cell or the dead cell, leaving the healthy living cell alone and allowing the body to heal. Now, think of it this way: in a wound where you have dead material and living material, for living material to replay to for living material to heal and recover from a wound, it would need to get rid of the dead material. Now, for your body to do this, it takes an extra long time. But with maggots, if they remove the dead materials, it allows for the process to go ahead much faster. What was also found was that these maggots releases certain chemicals such as urea and allen, allen, allantoin, which helps to kill bacteria. So not only do these maggots remove dead cells, they also help to prevent infection as well. Finally, you have apitherapy. Apitherapy, we previously mentioned, is basically use of any bee products. Right now, this can be bee bread, royal jelly, or bee venom. Bee bread are used in cultural traditions mostly for therapeutic physical treatments such as swellings, pains, and so on. Royal jelly is more favorably used under condition where you have liver disease or fever. But the true medical use, or the more popular one for, is from honeybee venom, which has a peptide named melittin. Now, melittin is used to treat persons with sclerosis and um, arthritis, rheumatoid arthritis. What it does is that it blocks inflammatory genes caused by these conditions. And when it blocks these inflammatory genes, it reduces pains and swelling, which would have come about. And by doing such, it gives the person relief, right? And there are basically two ways it can be administered. You can basically have the bee directly bite or sting the person, injecting the venom, or it can be inserted with injection, or as it says here, intermuscular injections is something similar to, like, EpiPens and the insulation injection. And with that, that is basically the end of my presentation. And those are the medical benefits of insects.